All right, welcome to part 2 of our intro to fractions. Let's get started. All right, so we talked about what a proper fraction is, what an improper fraction is, and also what a mixed number is. We in fraction land, which is where we are now, last chapter was all about whole numbers. This chapter is all about fractions. We love improper fractions. We like proper fractions too. They're cool. But what we really don't like are mixed numbers. Mixed numbers do not help us. They actually hurt us. They are not helpful to us at all. And they actually hinder our progress at every turn. So anytime we can get away from the mixed numbers, we do. And I'm going to show you how to do that right now. All right, so this is probably the most used trick, and not really trick, but process I'm going to give you that you will use this chapter and really beyond. You're going to use this from now till the final. So in order to write each number or mixed number as an improper fraction, what you're going to do is you're going to use multiplication and addition. You're going to take the denominator and the whole number, okay, and you're going to multiply them. So you're going to take the denominator times the whole number, and then you're going to add the numerator. And that's going to equal an improper fraction. Okay, so we take 2 times 5 and then plus 3. And it keeps, all right, you keep the denominator. So we're already going to write over 5 because we want to keep our original denominator. So really we're doing all of this to figure out the new numerator. So 5 times 2 gives us 10. Okay, and then plus 3 equals 13. So our answer is 13 over 5. So 2 3/5 as an improper fraction is 13 over 5. All right, let's try the next one. We're going to keep the over 9. And then what we're going to do is we're going to multiply this, and we're going to add that. So what that looks like is 6 times 9 equals, so 6 times 9 equals 54, plus 1 is 55. So if I rewrite that, I get 55 over 9. So you see how that becomes an improper fraction. So if it's a mixed number, it will definitely be an improper fraction because anything over 1 will be an improper fraction. And we'll talk more at the live about why that is. All right, so let's try the next one. We're going to have the denominator of 7, okay, because we keep our denominator. So we're going to have the denominator times the mixed number, or times the whole number, and then we're going to add the numerator. So we have 7 times 11, and that equals 77 plus 5, and that's 82 over 7. So that's how you turn a mixed number into an improper fraction. You must understand how to do that. If that didn't click, please stop, pause the video right now, rewind, go back and watch that again. All right, if you're okay with that, move on to the next part. All right. The next thing we're going to do is we're going to do that process backwards. So now we have a mixed number, now we have an improper fraction. You see that because all of our numerators are bigger than our denominators, 4 over 3, 9 over 3, 41 over 8, and we're going to turn it into a mixed or a whole number. Okay? So how do we go back? Well, we basically have to figure out how many times 3 goes into 4, or 3 goes into 9, or 8 goes into 41. Well, that sounds familiar. And we've seen something like this. We've seen this because we know that a fraction really just means division. And we've done this before. So we know that this means that we're on the outside of our division problem. Down and out, right? Down and out with division. Again, if I write it, you write it. Definitely take these notes. So with our division problem, we're putting 3 on the outside and we're putting 4 on the inside. So now we do our division problem just like we did in the last chapter. 3 goes into 4 how many times? It goes in once. What goes up must come down. 1 times 3 gives me 3. I subtract it and I get a 1. Well, I can't do anything else. I'm done. So last chapter, I was using a remainder. I would say my answer was 1, remainder 1. But I was kind of getting you ready for this chapter because I said, oh, well, we could also write it how? We could write it 1, and then we wrote it 1 over 3. Remember that? We said that this was the numerator, and this was the denominator. And that's exactly what we're going to do right now. This is the whole number. This is the numerator, and this is the denominator. So your answer is 1 1/3. All right, let's move on to letter B. We have 9 over 3. So 3 is my outside number, and 9 is my inside number for my division. And now I say 3 goes into 9 how many times? My answer is 3. And when I do my what goes up must come down. 3 times 3 is 9. And I actually, for this one, get 0 as my remainder. So my answer would be last chapter, 3 remainder 0, or just 3. Now, if I wrote this as a fractional remainder, I would get 3 and 0 over 3. But 0 over anything, or remainder 0, just means my answer is 3. So this is a whole number. This is not a mixed number. This is a whole number. I have no remainder. It goes in evenly, and I'm all done. All right, let's try the next one. 8 is my divisor, which means it's my outside number, and 41 is on the inside. I say 8 goes into 41 how many times? And my answer is 4. What goes up must come down. 4 times 8 gives me 32. Oops, I lied. 5. What am I thinking? All right, 5. 5 times 8 gives me 40. Caught myself there. And when I subtract, I get 1. So I'm definitely done because 8 doesn't go into 1. I don't have anything to bring down. So my answer from last chapter would have been 5 remainder 1. But fractionally, it's 5 and 1/8, right? Because this is my numerator and this is my denominator. And that's how I want to write it when it asks me to find the mixed or whole number. So again, we're moving through now. Last chapter, I could write it with just a remainder. This chapter, I want to write it as a mixed number. So it's really going to be important for you to pay attention to what the directions are asking you. If they ask you to divide and write or express your answer with a remainder, you want to write it like this, 5 remainder 1. If they ask you to write it as a mixed number, you want to write it 5 and 1/8. It's all going to depend on how the directions ask you to write it. That's how you're going to know. All right, let's look at the next section, number 3. Find two fractions equivalent to each given fraction. Now, this is very similar to last chapter where they asked you to find multiples. Okay? So, fractions can be simplified. So if I say that I ate half the cake, okay, this isn't an example, but if I say that they ask me, if I say I ate half the cake, well, I'll give you an easier example. If I say I ate the whole pizza pie, okay, that's one way of saying it. I could also say I ate 8 out of 8 slices, right? Now, say I cut each of those, you know how, when you have little kids, like you slice them smaller. Say I slice each of those smaller for my little kids, and now I say, oh, well, I ate 16 of the 16 slices. Saying any of those is the same thing. I still ate the whole pizza pie, right? No matter how small I cut them, no matter if I sit down and eat it all in one sitting, I've eaten the whole pizza pie. So equivalency is doing the same thing, right? When they're equal. So how do I do this? Well, basically I want to find multiples of this fraction. So if I multiply the bottom by 2, okay, just like I did, if you forget about the top for a second, 8 times 2 gives me 16. Well, what if I multiply it by 3? 8 times 3 gets me 24. But now I can't just worry about the bottom, just the one number, like I did last chapter. Remember when I did the multiples? 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, and I listed them all out. Because now I have a top to worry about too. So now I have to worry about the top as well. I have to do 1 times 2 and 1 times 3. So 1 times 2 is 2 and 1 times 3 is 3. So 2 over 16 and 3 over 24 are actually equivalent to 1 over 8. They're just the unsimplified version of it. If I divide 2 over 16, if I divide both the top and the bottom by 2, if I cut both of those in half, okay, or divide them both by 2, I will get back to 1/8. See how those are equivalent? And if I cut both of these by 3, I will get back to 1/8, making all three of these equal to 1/8. They are all equal fractions. So 1/8, 2/16, and 3/24 are all equal fractions. All right, so let's do the same with the next one. 3/10. Okay, so let's do multiples on the bottom. So 10 times 2 and times 3. So 10 times 2 is 20. 10 times 3 is 30. So if you do it to the bottom, you have to do it to the top. So 3 times 2 is 6. 3 times 3 is 9. Very good. So 3/10, 6/20, 9/30 are all equal to each other. All right, let's do it with 3/4. So 4 times 2 and 4 times 3. 4 times 2 is 8. 4 times 3 is 12. So if I do it to the bottom, I have to do it to the top. 3 times 2 is 6. 3 times 3 is 9. So 3/4, 6/8, 9/12, all equal. All right, now on the bottom, this is similar, but they've given you a bottom, and they're telling you they're equivalent fractions. You have to figure out what they've multiplied to get that bottom, and then you have to figure out the top. Okay, so in order to get from 4 to 12, and actually the one from up above might help you, okay? In order to get from 4 to 12, what did we multiply by? And your multiplication chart will really help you here. We multiplied by 3. So if we do it on the bottom, we have to do the same thing to the top. So if we multiply by 3 on the bottom, we have to multiply by 3 on the top. So 3 times 3 gives me 9. So the equivalent fraction that would be equal to 3/4 is 9/12. So the question mark, the number that we had to find, was 9. All right, so for this one, here's the first problem. The first problem is we're comparing a whole number to a fraction. So rule and trick number 1 here that I'm going to give you. You can put a 1 under any whole number. Okay, so 5 is a whole number. We can put it under 1. Or we can put a 1 under it. I'm sorry, that came out backwards. So now what did I do to get from 1 to 15? What did I multiply by? 1 times what equals 15? 15, right? 1 times 15 equals 15. So if I do it to the bottom, I have to do it to the top. So 5 times 15 equals what? Again, your multiplication chart will be very helpful for you. Okay, 5 times 15 equals 75. Okay, so 75/15 is your equivalent fraction, and really the question mark that you were looking for is 75. And letter C, we have 8 times what gives me 56, and that's 7. Whatever we do on the bottom, we have to do on the top. So 7 times 7 gives me what? And that's 49. So 49/56 is my equivalent fraction. And the question mark they were looking for was 49. All right, let's look at the next page. All right, looking to simplify. This is where GCF, these things that you thought were going to go away, they come back to haunt you, okay? In, a spooky Halloween kind of way. So if you look at 6 and 9, and you look at factors, 1 and 6, 2 and 3, 1 and 9, 3 and 3. What is the GCF that they both have? The greatest common factor. It's a 3, which means that the greatest common factor that they have, the number that they have divisibility-wise, the number that they are both divisible by, is a 3, which means that you can divide the top by 3 and you can divide the bottom by 3. And 6 divided by 3 gets you 2. And 9 divided by 3 gets you 3. And that will be your simplest form of that fraction. Now, in some cases, you can pull out a smaller number, like I'll show you here, like 10. So say 10. 10 is a even number, right? So you can cut it in half. So if I cut 10 in half, I get 5. And if I cut the bottom 10 in half, I get 5 again. But now, 5 and 5, do they have something in common? Yes, they both have a 5 in common. So because they're the same number, you end up with 1 and 1. And that really just equals 1. Now, you might have known that from the get-go because 10 divided by 10 just equals 1. So you could have just said that right from the get-go, 1. So I'll show you in letter C, there's 2 ways to go about it. If you see that they're both even numbers, you can cut them in half. Kind of like what we did with the prime numbers, the prime factorization, the factor trees. So if I just start cutting these in half because I know that they're even, I get 18 over 72. They're both even, so I do it again. I get 9 over 36. Okay, now 9's not even, but I'm going to go along the same thing I did with those factor trees. 2 doesn't work, but 3 does. So now I pull out a 3. And when I say pull out, I'm dividing. So I divide 9 by 3 and I get 3. I divide 36 by 3 and I get 12. Okay, I do it again. And 3 divided by 3 gets me 1. 12 divided by 3 gets me 4. So now I'm done because once I get a 1 in there, I know I'm done because I can't divide 1 by anything. But here, watch. I could have done my GCF, which definitely would have taken me a couple more minutes in the beginning. I say 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. I say 1 times 144, 2 times 72, 3 times, 48, 4 times 36, 5, 6, 24, 7, 8. It would help if I had my multiplication chart handy. Times 18, 9 doesn't work. Oh, 9 does work. 9 times 16. 10 doesn't work. 11, 12 does work. And I'm done. Okay, so this took a little bit, it was quicker at the, or it was a little bit longer at the start, but here's what you also should have seen too. As soon as you saw this, that's a GCF, okay? Because this is the biggest number that you can pull out of a 36. And you know it because it's literally the biggest number that can come out of there. So when you have 36 over 144, you can divide by 36 on the top and 36 on the bottom, and you can get 1 over, and you know what it's going to equal, because when I divide 144 by 36, I have to get 4. So I'm going to get that right away. So I actually didn't really need to go far, because once I get to this number, I'm quickly going to know what that simplifies into. All right. So here's the thing too. Anytime we work with fractions, we have to simplify. So simplifying is going to be very important. Okay. All right. So between each numbers, compare using greater than, less than, or equal to. Anytime we're comparing, it's going to be a less than, greater than, or equal to, because numbers can always be either greater than, less than, or equal to. There's always a chance that they are equal. If we have, here's the first thing you need to look for. Always check number 1. Are the denominators the same? If they are, you're good to go. If they're not, you're not good to go. If they're not, we have to do work, and we'll talk about what we have to do. So, right away, letter A, if they're the same. So you have 20 pieces of something, okay? You have 7, your brother has 11. Who has more, okay? Your brother, okay? You're comparing apples to apples. So with the same, when the denominators are the same, okay, you're comparing apples to apples. However, in letter B, when your denominators are not the same, okay, you are not comparing apples to apples. You are comparing apples to oranges, and this is when things get sticky. So what happens here is this. You need to, this is where your LCM comes in, your least common multiple. Now, the easiest way is to find your LCM, okay? There is another way to do it. So you can either find your LCM, or you can just do this, okay? You can take whatever's on the left and multiply it by the right, and you can take whatever's on the right and multiply it by the left. What I mean by that is this. We're going to take this side, and we're going to take this side. We're going to multiply this but over here, and we're going to multiply this over here. So we're going to multiply the 9 here, and whatever I do on the top, I have to do the bottom. And we're going to multiply the 8 over here, and whatever I do on the top, I have to do the bottom. Okay? Now, when I do this, I multiply the top with the top and the bottom with the bottom. So, on the top, I get 9 times 1, which is a 9. And on the bottom, I get 9 times 8, which is 72. On the right, I get 8 times 1, which is 8. And on the bottom, I get 9 times 8, which is 72. If I did this right, my bottom should now match like they did in A. and I should be good to go. And I should be good to compare. Now, I have 9 on the left and 8 on the right, which makes the left more and greater. So the 1/8 is actually larger. Going back to my original problem, the 1/8 is actually larger. Okay, so let's use the same logic here. Okay, it's the denominator that you do it with. Okay, so I'm going to set myself up. I always set myself up with the parentheses. I'm going to bring my 6 over here. I'm going to bring my 8 over here. Okay. I'm going to multiply by 8 on the top and the bottom. I'm going to multiply by 6 on the top and the bottom. And again, I do this when my denominators don't match. Okay? I multiply the tops with the tops, the bottoms by the bottoms. So, over here on the left, I get 8 times 5, which is 40, over 8 times 6, which is 48. On the right, I get 7 times 6, which is 42, over 8 times 6, which is 48. Again, my bottoms should match at this point because that's the whole point. I need my denominators to be the same. Now I'm comparing the tops. So once the bottoms match, you compare the tops. Okay, so 42 and 40, so my right side is greater. All right, so letter D. Problem with this one is that it's a mixed number to start. I can't have mixed numbers. So I need to first turn them into improper fractions. So that was step 1 from this worksheet. Number 2, then I need to make the denominators match. Then I need to compare. Okay? All right. So, in order, this will give you practice for the whole shebang. Okay. Seven times 2 plus 5. 15 times 2 plus 9. So 7 times 2 is 14 plus 9. 7 times 2 plus 5. So 7 times 2 is 14 plus 5 is 19 over 7. 15 times 2 is 30 plus 9 is 39 over 15. We're setting up our parentheses on both sides, multiplying by 15 over here, multiplying by 7 over here. So 15 on the top and bottom here. multiplying by 7 over here. Now, these are bigger numbers, so I have to be careful because I've already been tongue-tied and made a couple mistakes. And I just don't want to mess up at this point because I could get the whole problem wrong just by messing up one number. Okay, and I'm not at the point where I'm using a calculator yet. So, 19 times 15. All right, that's 45. 9, 1, 5, 8, 2. All right, so that's 285 over 15 by 7. That could be on your multiplication chart. Hopefully, when you guys check me, I'm right. 105, 105. These should be improper fractions because, again, I'm starting with improper fractions because I'm starting with mixed numbers. 39 times 7. $273. And again, I'm going to just do it just to check myself. 105. All right, so I have 285 over 105 and 273 over 105. My denominators do match, which leads me to think I did it right. And so I'm comparing 285 and 273. So 285 is bigger, which means that 2 and 5/7 is greater than 2 and 9/15. And that's it, my friends. I will see you back here for more fraction operations.